Some interesting things happen when you take a right triangle, like this large one drawn here, and you drop an altitude from the right angle to the hypotenuse. And what results are two more triangles. We have a tiny one here on the right, and we have a medium-sized one here on the left. And those three triangles are all similar to one another. In other words, all their angles match up. And you can see this if you, for example, assign an angle measure to this angle on the left. So I'm going to call it 20 degrees. Then, because the large triangle has to add up to 180, the other angle in the large triangle must be 70 degrees. And if that's the case, then this angle right here in the small triangle must also be 20 degrees, and this angle here must be 70 degrees. So as a result, all three triangles, this medium one, this small one, and then finally the large one, are all 20, 70, 90-degree triangles. Alright, now I'm going to erase these angle measures because those angle measures were just an example, but what we're going to do from here on out works with any of those angle measurements or any angle measurements. Alright, what I want to focus on now are the sides of the triangle. I want to focus on X and Y and Z, the two legs and the altitude of the right triangle. And then I'm going to assign values to the hypotenuse across the bottom. I'm going to make this part of the hypotenuse equal to 10 and that part of the hypotenuse equal to 4. And what happens in this situation is that X, Y, and Z are all geometric means. X turns out to be the geometric mean of this piece of the hypotenuse and the entire hypotenuse. So it is the square root of 10 times 14. Z turns out to be the square root of that part of the hypotenuse and the entire hypotenuse. So in other words, 4 times 14. And then Y turns out to be the geometric mean of each piece of the hypotenuse, 10 and 4. So the square root of 10 times 4. Let's now see why that happens. If you're standing at this angle, for example, then from the big triangle's perspective, the cosine is x over 14. So I'm going to write that down, x over 14. And then if you're standing at that same angle, from the medium triangle's perspective, the cosine is 10 over x. And if we cross multiply here, we'll get x squared equals 14 times 10. So x equals the square root of 10 times 14. Okay, let's look at the other angle over here. If you're standing over at this angle, the cosine of this angle is 4, the adjacent leg of this tiny triangle, over the hypotenuse z. So I'm going to write down 4 over z. And then again, if you're standing at that angle and you're looking at the big triangle, the cosine is adjacent over hypotenuse, or z over 14. And again, just like before, if we cross multiply here, we get 4 times 14 equals z squared. So z must be the square root of 4 times 14. Okay, let's look at the middle one now. And for this one, let's again stand at this angle. And the tangent of this angle, using the medium triangle, is y opposite over 10 adjacent. So I'm going to write down y over 10. And then, if you're standing at that angle, which is the same as this angle, remember those two angles are the same, the tangent of this angle is 4 over y. So I'm going to write down 4 over y. And if we were to cross multiply here, we'd get y squared equals 10 times 4. So y is the square root of 10 times 4. Okay, let's do a couple of examples, and I have a few. In this first example, the right triangle is oriented differently from what you saw in the previous slide, but there's the right angle, and then there's the altitude. So this leg is the geometric mean of this piece of the hypotenuse and the entire hypotenuse. So x is the square root of 9 times 25. And if you clean that up, you get the square root of 9 is 3, the square root of 25 is 5, so x equals 15. In the example on the right, here's the big triangle. So x is the altitude of the big triangle, so it's the geometric mean of the two pieces of the hypotenuse. So x in this case is the square root of 7 times 9. And of course x will then be equal to 3 times the square root of 7. Okay, in this final example, here's the big triangle. We know that the altitude of 12 is the geometric mean of x and 16. So our unknown now is going to be inside the square root. 12 is the square root of x times 16. So to solve this problem, we need to get rid of the square root first, so we'll do that by squaring both sides. So now 144 is 16x, and x equals 9. And that's it.